Okay, standard electrode potentials. Definition, you need to know it. The EMF of a half cell compared with a standard hydrogen half cell under standard conditions of 298 Kelvin, 1 mole per meter cube for all concentrations, and 1 atmosphere pressure. Okay, so here we've got two half cell equations. Okay, and here's the standard electrode potentials along here. The more positive one is the one that will go forward when two are linked together. So you can't have a half cell by itself, you have to link it to another one to make these reactions occur. Okay, so when we link 2 and 3 up, the more positive one is 3, so 3 will go forward and therefore gains electrons, not donates. Okay, and the other one, the ion, will go backwards and donate electrons. Okay, so the more negative one out of 2 always goes backwards and donates electrons. Okay, so if something's feasible, then the difference between the electrode potentials has to be bigger than 0.4. Okay, well, it certainly has to be positive anyway. 0.4 is a rough estimate. So between those two, then we took those two electrode potentials and we do the more positive one, take away the more negative one. So we do 1.36, take away 0.34. Okay, the reason we're taking this one away is because it's going backwards. And that gives us 1.02, so in this case the reaction is feasible. When we write the overall equation for them, we have to balance out the electrons. So because there was 2 and 3, we times this one had 3 electrons, so we times it all by 2 to make 6. This one had 2 electrons, so we times it all by 3 to make 6. Okay? And then remember that this one's going forward and this one's going backwards. Okay? No, so that one needs to be, that one's going backwards, so it's like that. So it's got iron and it's making 2 lots of Fe3+. Okay? So the chlorine has gained electrons to make chloride. The iron donates electrons to make the iron 3+.